Right, welcome everyone to week 9. Can you believe it? Can I just check, Rosalind, can you just nod if we've got visuals and sound? Thank you so much. I really appreciate that before we get going. Look, small group this morning. Hopefully more will join us. If not, this will certainly get recorded and will be available for people to listen and hear. What I might do is just shut down the little video panel. That way we don't appear on the screen capture of this. And as much as we can do that, it's probably good not to record our images on the screen. And we'll just hide the video panel. Beautiful. So we won't appear, even though we know you're at least Samara and Rosalind are here on board. So let's have a look. This week we're doing the second week of biological sciences, and we're very much in the full swing of this whole notion of the digital cards, of flipping the classroom, and of doing biological science investigations, which are, let's face it, they're some of the most fun investigations to do. I mean, it's really easy to make your own DNA, capture your own DNA, all really simple biological tasks that, involve no heat, no problems, no damage, no danger. And we'll talk about some of those strategies as the weeks go by, as we get closer to submitting this assessment task. But online this week, in week 9, you'll see I've put up a lot of different examples of biological science investigations, including a great unit from Reef Guardian, which they do some fabulous stuff, really, really good stuff. And the reason why I put it up there is because, it can also be a really, really good learning sequence for assessment task number 2 for your digital cards. Let's get going. The first thing I'll do is get my highlighter, and so we can do some highlights, some really important bits that I think are important anyway. And this week in the Moodle, we talked about biology 2, children investigating small animal behaviours, and introduced you to a woman by the name of Kathleen Metz. And Metz is a really, really interesting educator for a whole range of reasons. And one of those, of course, is that she openly challenges Piaget's notion of stage-based or schematic. Whoa, can I ask someone to mute their microphone there, please? Yeah. And
Sorry.
Thank you. And Kathleen Metz challenges Piaget's notion of cognitively bound developmental stages. She argues that science can be taught, and this is one of the themes of this course, that children are scientists. It's only until we butcher their scientific processes or that we fail to direct them in powerful ways that their science breaks down, that they have trouble with their worldview and world images. So she argues young children are able to think and work in more sophisticated levels than we actually think they are. They carry out experiments all the time. And they do that, they watch you constantly. I remember many years ago, my youngest daughter was about 4 years old, and going around that time was a very, very popular TV commercial: if you drink and drive, you're a bloody idiot. And you may remember that. So we were up at down in Brisbane, up on the mountains, and we were coming home after a day's hiking, and I pulled out my bottle of water as I'm driving us home, and I'm drinking, and all of a sudden this little face gets really, really rigid, and the eyebrows knit in the middle, and she says to me, "Dad, you're a bloody idiot." And, of course, this is the whole notion of the child applying the science, applying, the experiments that they've come across in the world, and applying it to their own inferential thinking. And, of course, sometimes it can be quite humorous, sometimes it can be absolutely beautiful, and sometimes it can be quite disastrous. And that's why we have teachers, to intervene and direct, to help construct that and put it in directions where it's going to be powerful. So Metz also says that we've got to allow the practice of science in purposeful contexts. And these are ways that engage children's imaginations and their hands. Okay, and here we're going to talk a little bit about the early years framework, because it really is essentially play-based. And we've got the processes of observation, questioning, investigating, design, and the management of data. Now that's going to come through this week when we look at it. So, and the reason we're doing this is we're looking at learning sequences in biology. We're looking at investigations. What we want you to do for assessment task number 2 is to actually piece together a science investigation using digital formats and digital fora. So we'll have a look at ways of doing that. Okay, it's not something we only need to do in the classroom. It's something that, as we know, Russell Stannard talked about the digital affordances that we get from using technology, and flipping our classroom gives us more time in the classroom to work face-to-face and one-on-one with kids. So Metz goes on to argue that children tend to be novices in most domains, and we know this. I mean, we have a universal Declaration of the Rights of Children. We see them very much as novices. We see them as small, substandard, flawed human beings. We even have legislation, and no other group of people has legislation written about them, but children do. So, we have a problem with children. We may not want to admit that as a society, but we do. We treat them quite differently. And of course, this comes through when we start looking at them as learners as well. So when we look at the notion of working with animals, children get particularly excited by this. And that's one of the reasons why I'm suggesting that we may want to look at some of these basic observational invertebrate type units around the schoolroom. Feathers, furs and leaves is a very good example that we saw coming through assessment task number 1, some of the primary connections unit. But the first stage introduces the notion of the animal as interesting to observe. And we can do that because we can use similarities in different framework. They're very different to us, different in size, different in mannerisms, different diet, different habitat. We can look at all of these different creatures. And the skill that we want students, the scientific inquiry skills, is to observe the behaviour and then discriminate what is seen and the anthropomorphic conclusions that children tend to make. So, is a fish looking around at everybody through its glass, in the fish tank? That's a human observation. We're attributing anthropomorphic, attributes to that particular animal. It behaves in human ways. And this is one of the very things that we can do with a very beginning science unit to break it down on biology that, in 10 animals, if we look at monkeys have got their own problems. They don't need to be like us. Dogs have got their own issues. They don't need to be like us. It's only us that thinks they're like us in the way that we do. The anthropomorphic tendencies, we attribute human behaviour to animals. And that can be the basis for a really good science unit. So we observe the behaviour that predominates rather than get sentimental about what's going on. And this is very difficult with Walt Disney and the Disney movies. I mean, while they've opened the door to so much imagination, they are also responsible for so many attribution errors in children's frameworks. They really, really are. And, they're not alone. The whole notion of stranger dangers, we now know is in fact an attribution error, that most children are more likely to be harmed by someone close to them than someone who's not. So we're learning a lot about this kind of stuff, about our assumptions and our paradigms. But Metz goes on to argue that from a set of personally observed behaviours, the child can make suggestions about that behaviour. Now, this is the science of childhood. This is what we're talking about. When we talk about Piaget, every child is a scientist. We can also look at Picasso, everybody's an artist. We can look at all these wonderful quotes, but all we need to do is structure for these personas, for these identities that children use. We only need to structure a format, an inquiry process. And we can look at certain behaviours and we can tally the frequencies. Okay, so we're bringing to it here the scientific method. Now, the scientific method is much maligned. But we're actually going to treat it as a really good tool for directing learning. That's all we're doing. We're not saying it's infallible. We're just saying it is a tool and a framework, the science inquiry process. They can observe behaviours. They can identify them and chart them, what is the behaviour. Then they can actually tally the frequency of that particular behaviour. How often does it appear? Okay, and it's non-prescribed observation. And then we can look at it over time. What happens to that behaviour over time? Is it more frequent during particular times of the day? Is it related to eating? Is it related to something else? And once we do that, we can proceed through a staged analysis. And this is not hard to do. As you can see, these young children can barely spell. Again, that's a science literacy issue. But, using little charts, they're mapping the movements of an animal around certain spaces. And they're doing it by putting numbers down on that space. They're observing this animal and watching Pumpkin move around as Pumpkin does different things. And for every different thing Pumpkin does, they put down an indicator. And all of a sudden, they're starting to map this animal's behaviour. This is really good observation of the likes of, that Charles Darwin did when he was a scientist. So we can look at the observation and the inference. So here we're leaning towards the POE. What do we infer from this observation? The inductive logic that we've got going through here. It's flicking its tail, and the fish is flicking its tail, and the inference is it's got something to do with swimming. It's opening and shutting its mouth. Okay, can suck oxygen out of the air. These are all the little things that kids are coming up with when they're looking at the observation of these animals, and this fits in nicely with Metz's principle that children are scientists. They do think scientifically. And the best thing we can do as a teacher is get out of the road and let them inquire, let them develop those inquiry skills so that they can then start to explore their world as scientists would choose to. And each child, for instance, in this case, only had to watch one mouse and observe what the mouse was doing when the teacher called now every 50-second intervals. And you can see that's not sophisticated science. But you can see it is definitely connected to data, and the data then is linked to observations and the observations to inferences. And all of a sudden, we have this scientific process occurring. So when we look at a learning sequence, and that's the whole challenge here with your digital cards, we want you to pick a learning sequence for children to consider data or to consider phenomena or consider observations. They may, in that period, for instance, you may show them a video and get them to do some time sampling. And from that time sampling, you may get them to list their observations, as we've seen in the last slide. And what can they infer from those observations? So you can actually send them home with the affordances of a flipped classroom. You can come up with some excellent video resources, and you can get the child engaged in this analytical, observational, predictive and inferential framework. They're already there doing it. They want to do it. And you see the sorts of tasks. They're not hard to do, are they? Tallying behaviours. Here we're looking at Panda. Panda, again, was a little mouse. What's going on with this little mouse? It's engaging in 1, 2, 3, 4, 5, 6 observable behaviours. The child has frequency analysis of each of these behaviours. We can move from here to graphs. We can move to charts. We can do comparative analysis over time, motion studies. We can do all of these different scientific objectives and learn about this animal's behaviour. But to do that, we've got to come in as a teacher, and here's where our assessment task 2 really starts to bite in, where it starts to get to the cut of assessment task 2. But we're starting to look at which of these can be investigated in the classroom and which cannot. Now, we've talked about Bloom's taxonomy in the year. I'm going to, earlier in the year, I'll introduce you to another questioning scientist today, an educator with a very strong philosophy on science. And they had the 7 levels of questioning, which we'll talk about today, just that you can use with kids, as you're going through your learning sequence. Work out where you want to pitch. Do you want to be at the knowledge and comprehension level? Is that where you're going to pitch your learning sequence? Or are you going to go to the other end of the spectrum where they're looking at, the applications and the model building and the inferential skills that they use at the upper end of Bloom's model? So how do we plan to do different investigations? What can be investigated in the classroom and what can't? How do we plan to do investigations? How do we determine research questions? How do we prepare materials? How do we decide what conclusions can be realised? In other words, what predictions we might make? And how do we push children to collect, analyse data, plan and present investigations, evaluate their own and others' work? This essentially is assessment task number 2. Now we can do it in a classroom. The question is, the challenge for assessment task number 2 is to imbue it with technology and see whether we can transfer it beyond the classroom to a learning task or a learning sequence for one or a small group of learners. Questioning and assessment. Okay, we can go on and look at this. The role of questioning. Working with animals stimulates curiosity in children. We know it does. And teaching them to ask questions is the biggest skill we can give them in towards developing their metacognitive skills. Now, metacognition is thinking about thinking. So what we want children to do is inquire, is to develop a line of inquiry skills. That inquiry process is going to take them down a long journey where they can actually identify a set of knowledge, scaffold that knowledge, link the knowledge schema, and then apply that knowledge schema to a real world situation, and then hopefully generalize that situation to other contexts and other questions that they may have. So we can see here we've moved from the simple observation and the frequency charting. We're now looking at presenting that data. We can see what's going on here with the little mouse. And we're presenting the data and having a look at its most frequent behaviours. And children are learning a whole lot of different literacies while this is going on. We can pin a question sheet around the classroom. We can have that living 24/7. It can be live. Children can add questions to it at any particular time. Okay, it can be a community inquiry board. A wonder wall is also a very, very nice way, a very visual way to personalise these kinds of questioning and data collection activities for kids. And LSkeets is these categories, these 7 categories of questions, you know, working to kids from very basic observations, an informal hierarchy, working from the very induction of meeting the animal or meeting the inquiry, right through the process of taking that inquiry through to its natural conclusions. And Elsguest, you know, talks about 7 levels of questioning. And let's have a look at what they are now. He raises the notion of, you know, when children watch birds, it might give rise to what he calls his level 1 style of thinking, which is really about focusing their attention. What's its beak like? What colour is it like? What colour is it? Now, if anyone's looked at the Reef Guardian unit that I actually put in the week 9 materials, you know, it's got the beak. It's got the little beak investigation, you know, which is fabulous. It's a great little investigation, you know, for cracking open hard substances. And you basically got to experiment with different beak-like structures and observe, record, predict. And so, you know, we're doing all of these different things. These are level 1 style thinking, and it's attention focusing. Elsguest goes on to say that level 2 quantitative questions are related to counting and comparisons. Okay, we can see ourselves doing this, can't we? We can actually set an observational video. We can then get them to count, identify certain behaviours. We can get them to describe those behaviours. We can then get them to count the frequency of those behaviours, and then we can make predictions about those behaviours over a long period of time. Okay, all of these different things. Level 3 qualitative questions are powerful, looking at similarities and differences. So here we're starting to get the students to discern, you know, the scientific process. What do they have in common? What are they different? Okay, what facets or attributes are different? So the level 3 qualitative questions are more powerful. We're starting to narrow down hierarchies. We're starting to introduce those processes of classification. Level 4 thinking, we move to action questions. What would happen if the spider's pathway was blocked by water? Really interesting question. Really interesting to predict. Some spiders will simply walk across the water. Some will make a bubble and float across on a bubble. There are a whole range of beautiful observations you can make when a spider's pathway is blocked by water. And, you know, these are the sorts of action questions we want kids to get to. We can see them going down this hierarchy, or really up the hierarchy in terms of complexity. They've moved very much from focusing attention through to actually differentiating, you know, counting and comparing. And from there, we're starting to look at similarities and differences. We're starting to, you know, discriminate. Level 4, we're starting to look at action questions. We're starting to look at, you know, how these animals perform in a real life. Level 5 questioning usually poses a problem, you know, and they're generally context-bound and dependent on prior knowledge. So little questions, you know, some of us used the mealworm unit for assessment task number 2. You know, how do we find out whether a mealworm goes under the bran to avoid light or to eat? So there's 2 assumptions. We can watch a mealworm. We can watch it go, for instance, in its little glass chamber or its last glass water wall, and it can go down under the ground. What does it do there? Some of our predictions might be it's gone there to eat. It might have gone there to avoid light. It might have gone there to shed. Okay, a whole range of things that a mealworm will do. But again, how do we observe? Okay, pose the problem. How do we find out? How do we create a science around finding out what the mealworm does and why? Level 6 talks about cognitive and affective linking questions. How does a rabbit dig a burrow? Really interesting question. How does it do that? Okay, get the children to visualize and imagine, you know, here we've got role play, here you've got drama, you've got a whole range of things that you can do. Level 7 involves reasoning questions, which may be metaphysical or philosophical, and they've got no agreed answer. You know, for instance, are snails good parents? Okay, or what makes a snail pretty? A whole range of things that we can look at. You know, and these may seem like silly questions, but when we look at a child, you know, in the process of science and investigation, we can see that the hierarchy that the child may move through. It may look first of all at the snail. It may get the physical descriptions. It then may start to count and compare, you know, what different snails do, how they behave. At the qualitative level, it may look at similarities between snails and other species. Action questions. What happens when snails need to go uphill? What happens if they fall in water? Level 5 questions. Of course, action questions often involve an ethical level 2, you know, about torturing insects can be quite undesirable. Level 5 poses a problem. Okay, you know, the mealworm. Why does the snail do this? How does the snail have a mouth? How is a snail going to eat its food? Really interesting problems. How do we observe this? Cognitive and you know, again, going through the hierarchy. So the nice thing about ELSCGEES is there's nothing new there. Okay, it's probably good common sense, and that's why I'm throwing him up to you as a theorist at the moment. But the question here is, how are you going to use this in your own digital card? How are you going to piece this together in your own learning sequence? And ELSCGEES offers you, at least seven different levels or hierarchies where you can intersect with learner frameworks, and you can take control of that learning process, where you can interact around that particular question focus, that level of the hierarchy. Okay, and it's a really nice one when you think about it, because often with our digital cards, the big question is, where do we start? How do we do it? More on that as we get going. Rogoff talks about the socio-cultural perspectives. And we talk about, science and observation and participation and community activities, science around community activities. It's not the acquisition of competencies that we're talking about here. It's actually about how and what we do when we participate, how and what animals do when they participate, the very nature of transformative observation. So science then becomes a mix of languages, and it's got multimodal representations. We know that it's mathematical, it's graphical, it's artistic, it's linguistic. It's based in a whole range of tables, a whole range of, as Lemke reports, graphs, diagrams, science reports. There's a whole, discourse of science that our students need to become immersed in. And of course, as teachers, we can plan that immersion. We can lead it, we can structure it. That's what we do. We control, or we manage the pedagogical side of that. So teaching science involves children as active participants. And what we're looking at is processing inquiry, collaborating in deciding on their questions. What are the right questions? Giving the questions that students would ask, and one of the summative assessments, one of the best summative assessments you may ever do would be to get the students to write the questions to their own examination. If you're addicted to exams, you actually believe that's the best way of doing assessment, then get the students to write the questions, and you'll find they're generally harder than the ones that you would set. So get them to collaborate, okay? Questioning, get them to work around, their investigative designs, what they as scientists value, what they as scientists do. So for your digital card, we're suggesting you look at a lesson sequence, and this may make a little more sense at the end of this session, where we'll open the floor and have some questions. I'm going to present an example to you in this session about how one student's responded to this particular question. But we do lesson sequences all the time. Plants in the school ground environment is a lesson sequence. The school ground is a rich resource of material. It's right outside our door. And we can look at children's ideas about plants. They're not always rational. They're much less developed in their conception of animals. Let's face it, because children often see plants as background and animals as foreground factors. Children think plants are only alive when they've got flowers or when they're producing fruit. So green, in essence, is a natural state for a plant. It doesn't necessarily signify that it's actually alive. And plant movements, of course, are much more subtle. Okay, you don't often find children falling in love with a plant, but you do find them, for instance, becoming very emotional and very anthropomorphic about animals. And Biddulph in 1984 looked at this. It was a fairly seminal study. He took 115 11-year-olds, and not one of those students understood at that stage, okay, that fruit functions as a seed dispersal mechanism. 56%. Of 9-year-olds in a further study, and the only reason that the plants grew food was for us to eat. So we can see that, whilst these are partially correct, we can see that what we're hitting upon here are the misconceptions that we need to work with as teachers. And once we identify those misconceptions, we can then build a pedagogy around them. And we know from Assessment Task 1 and from our other studies, there are a range of pedagogies that we can apply. The ones we're looking at here are necessarily, and by demand, inquiry-based. That's the nature of the pedagogies. But they can be broken down into a whole range of different pedagogies, including problem-based, including guided inquiry, okay, including a whole range of different strategies that we can use in the classroom to achieve that inquiry purpose. So here's a little graph, for instance, from the studies. What's the main reason a plant has flowers? And we can see the breakdown here in 7 to 8-year-olds and 11 to 12-year-olds. And you can see how the schema varies because it just grows that way. So, we had one student believing that in the 7-8 group, and, 11 and 12, similar representation. To grow seeds, we can start to see the development of some stronger concepts to make it look nice. Now, that's beautiful, isn't it? And you can think that a year 7 to 8-year-old misconception would be that's the main reason a flower has plants. A plant has flowers, is to make it look nice. We can start to see, as the students get older, we can start to see some shift in their schema. We can start to see some analysis, but we can also see, for instance, that, there's still considerable error. There's still considerable misconception in these frameworks. So as teachers, we can never take, that science is given. We can never take that, what we think we've taught has actually been learned, because it constantly shifts over time. Plant nutrition, students by necessity or by habit find it difficult to conceptualize plant body mass, coming from invisible atmospheric gases and water. So they struggle with the whole idea of photosynthesis. That the sun's energy transforms atmospheric carbon dioxide and water to simple sugars and starches, which become food for the plants. We kind of get that as adults, but children do struggle with that concept. And there's a whole range of, activities you can do to actually reinforce those particular concepts. So when we look at phyla in the realm of plants, there's a number of broad phyla in the realm of plants, and the angiosperms, the flowering plants, are really the good ones to observe if you're building up a learning sequence. And in there, we also got other ones, conifers, ferns, mosses, and so on. Mosses are really, really interesting, particularly their relationship to soil. And also the behaviour of mosses as we look at our environmental degradation. When our top grasses and low shrubbery get taken away, more moss grows. What does moss do? It actually heats up the ground, keeps the earth warm. What does that do? It has a significant impact on other root systems. What does that do? That has an impact on vegetation survival, which has an impact on food sources. It has an impact on animal levels, and we can see the whole food web shifting. So all of these plants represent really, really interesting learning sequences. And what we've got to do is put our child pants back on and actually imagine ourselves in this world, how we're going to deal with it, how we're going to get excited by it. What are the questions that we want to ask? And children, some of the habits we've observed from Tunnicliffe is children tend to recognise and identify plants mainly in terms of their large-scale anatomy, okay, and where they live or where they're found. So, their leaves, essentially. So children should be encouraged to look at finer details, link plant, and we can do this again. Art is one of the big ways to lead to this. When we can actually look at how we get our students to observe those very first stages, what we ask them to observe, what structured tasks we get them to engage with. And that can actually impact on their final representations. That can impact on what they understand the purpose and science of plants to be. We'll come to that in a minute. We'll just keep talking about ideas about plant reproduction, because what we're looking at here is, one of your digital cards needs to be on the biological sciences. The other needs to be on earth and space sciences. We'll talk about that again at the end of the session, because I had a phone call today with one student who was working on this assignment and hadn't noticed that one card actually has to be on biological sciences and the other has to be on earth and space sciences. So there's a few common errors that we can make here in this assessment item. It's deceptively simple. So we're talking here about the biological side now, about plant reproduction. And we can look at, what that reproduction cycle is. And this makes great learning sequences: seeds, germination, seedlings, plants, bud to flowers, pollination, fertilization, fruit to seed, and of course the breakdown, decomposition. We can look at the whole purpose of adaptation by the plant and how it's fitted for survival in different environments. We can also look at, the musky rat kangaroos in some of our tropical forests and the role they play in collecting the seeds and burying them in the forest. It's just what they do. It's just their natural behaviour. And of course, a lot of our native species have survived because of creatures like, native creatures like the musky rat kangaroos, who, the gardeners of the forest. They'll collect the seeds and just store them. And ultimately, of course, if they don't come back to retrieve those seeds as a food source, those trees become trees and plants, and of course, they're naturally repollinating and refertilizing the forests. So flowers are the mechanism for sexual reproduction in angiosperms, and flowers have both male and female parts. So here we've got quite a few misconceptions again. And it's one of those action questions that we can get down to. Is the plant a male or a female? If so, why so? and we can start to challenge and look at some of these really, really interesting questions that kids may have thought about and may not have thought about, but certainly are now thinking about when you start to talk to them about flowers having male and female parts, boy and girl flowers. How do we know? How do we explore that? Pollen. We can talk about pollen and sperm, pollination, the transfer of pollen, fertilization, fusion of male and female. We could talk about all of these scientific processes, and this whole notion of opening up the ideas about plant reproduction can, of course, lead to comparison with animals, can, of course, lead to comparison with human beings, can, of course, look to chemical and energy transfers and a whole range of interactions beyond that. So we can look at all of these different processes once we set up this initial line of inquiry. Why do plants have flowers? Again, one of the common misconceptions, and I raised this a little bit early. Symington and White did a lot of studies, and see there's a lot of concept studies going back on in the 80s and 90s when we were looking primarily at science as an understanding and science as a knowledge base. We're now shifting that focus much more to science as a line of inquiry, as a way of relating and belonging to the world. So, these notions aren't probably as preeminent in our science units these days, but they represent minor steps of knowledge in our science processes. And why do plants have flowers? Okay, some really interesting conclusions and processes around this one. And you can see from what's on the screen there that it's got to do with birds and insects and pollen transfer from one flower to another. Anyone that grows pumpkins, and for instance, that your pumpkins are having problems growing, you're getting quite a few flowers, then the first thing you do is manually pollinate them. All these little things that we've learned as humans and gardeners, that appear on shows like Gardening Australia, that we're applying these sciences in our daily lives. So, in some ways, we too are adopting this scientific approach. But flowering plants rely on wind. It makes a really interesting study. The position of the stigma varies in different plant species. A really good question. What is the stigma? Let's look at 3 different plants. Why is the stigma different in all of these? What does it tell us about the plant? What does it tell us about the environment? What does it tell us about evolutionary advantage? Some really interesting notions. And following finally fertilization, the ovary of the flower becomes the fruit that contains, protects, and nurtures the seed. Now we can then have a look at that process and compare it. You can see the direct transfer to animal reproduction and human reproduction. So we can start to see what things have in common and what things are different. Now, all of these are really, really rich investigation opportunities. And as you can see, they don't require huge bangs to get them going. They can come simply from really, really clever, relevant, and student-driven questions. Your goal as a teacher is to engage them at this level of questioning, to open up the potential questions and bring them to the fore. A question for you, and I put this in the ebook for the week too. When was your last plant dissection? When did you last do one? Have a close look at the plants. They are absolutely fascinating things when you break them down and get them down to the different structures, the different parts they have. Why do plants have different means of seed dispersal? And you can do this by dissecting 2 or 3 different plants, different genus, and you can have a look at the different seed dispersal mechanisms, and all of a sudden you've got a wild inquiry going on. Why does dandelion release thousands of seed on the wind? Okay, you could then look at, for instance, seed passage, through animals like cassowaries in the forests. Okay, really interesting notion that the seeds get caught in their fur and travel from different location to location, as well as also the food they eat and the cassowary droppings. And then you can see the seeds living and thriving in there and doing very well. Why do some plants release seeds in water only? Muskrats, kangaroos, the farmers of the forest, are all eucalypts, flowering plants. All of these, as you can see, are incredible inquiry questions. And they can all be done quite easily, just by you as a teacher and the students around the school collecting a range of flowers, organising a plant dissection, and having a real-life event drawing in your classroom. Real-life drawing, okay? Now, this slide indicates the difference when we take our kids seriously. When we say to them, you are a scientist, let's give you the opportunity to act like a scientist. So we can see here these wonderful little attributions, I don't know when you saw a plant like that. Maybe I've seen once. But really, when we look at some of these representations our children have of plants, we've really got to question what we're teaching them, don't we? You know, but here we've got at least a plant that's developing some degree of schematic knowledge here, some relational knowledge, the parts of the plants, the feeding and the root systems. So there's some notion there of food transfer. But, you know, does the student actually indicate that it feeds through the roots, or does the plant actually feed through the leaves, or does it feed through the flowers, or where is the knowledge representation there? So we can see, you know, the very anthropomorphic little smiling flower here, through to this quite unusual tree, and through to the more conservative models, and to something a little more scientific. Whereas over here, these are the result of sketches from real samples. And you can see, just by changing our perspective as teachers, by changing our engagement strategies, that we're coming up with much richer, much more detailed, much more, you know, multi-layered examples of what plants actually are and what they do. So we're challenging stereotypical assumptions of the plant as a background apparatus, as a background creature. We're now starting to bring it into the foreground and look at its attributes, look at its features, look at its structures, and starting to investigate why they come together, how they come together, why they are what they are, why, you know, the different parts of the plant are in different places, why it varies from species to species. Now we are challenging what is here, you know, the dumbing down of stereotypes, okay? Don't accept the lowest common denominator. So assessment task number 2 talks to us about our TPAC, our technological, our pedagogical, and our scientific knowledge, or our curriculum knowledge and content knowledge. So we can see the interaction of these things is going to be, you know, where we bring it together in our digital card. So the digital card is a challenging task. Like assessment task number 1, it's deceptively simple. You know, you've got to come up with part A, where you identify 2 different pedagogies, and then you apply them to a year level situation in a science substrand related to a particular learning sequence, and then you tell us why each of those pedagogies is relevant, good and positive. Then you produce a digital card to reflect those pedagogies in action. And we can see between part A and part B, where you visualise the concept, where you've created the concept in part A of the assignment. Part B, you've produced it, and theoretically they should align. Part A and part B should align quite well. You'll finish up with 2 rationales and 2 digital cards, and ideally they will work. You'll say your TPAC, hopefully your content, your technology and your pedagogy will intersect to produce a really, really good learning experience for your kids. Here's a nice little one. Okay, now it's not a digital card, but you can see it's a very, very hands-on card. And this particular student, as you can see, handed out these activities, a great little task. And obviously the unit was about living together. It was about the environmental impact of cities and towns on regional settings and forests and rivers and water supplies. And what a fantastic activity. Look at this, 20 people, little Chico babies, 4 towns and wafers. 2 water sources, lemon tarts, and we can see them there in the solution. 30 koalas and 10 trees. So we have a little micro environment. And this teacher was trying to explore with the students about the impact, about the nature of adaptation, about how environments change and are impacted upon by human effort. Okay, and so we look at this, you can see the challenge here is they've drawn up a little environmental grid, and you must place all of your people and towns on the grid first. You must place both your water sources on the grid. Your people can't be more than 5 squares from a town. Why? Explore the issues. Travel, pollution, cost. Okay, the need for facilities and resources. You need to place your trees no more than 5 squares from a water source. Oh, why would that be? Look at the biology of trees, explore it. And ultimately, once you've gone through and hypothesized all of this science, the kids can produce this wonderful solution and then eat it. What a great response. So science, inquiry, doesn't have to be done in the guise of the scientific method. You can see here it's all about the constructivist work that teachers doing. The teacher has created this ZPD, has created this grid, and in the grid it's got a few parameters, and in that parameters are certain rules. The rules for society, the rules for structure, the rules for organisation. And we put that together, we can have a look at how the community and the environment interact together. And of course, it can lead to a whole range of further explorations. Another one, as you can see here, living together, scenario 4. There's a whole range of scenarios for this particular activity, and the student went on to explore the impact of different communities, different cities, different towns, different settings, and the focus of this particular one was sheep. Now, sheep have played an horrendous role in redefining the Australian environment. In terms of their impact on the environment. Cows equally so, with methane and being the most predominant issue. And yet the natural grazers of this area, the kangaroos, represent a perfect balance. So there's a lot of science involved in this. We can take kids down this path and explore that sustainability stream quite well. 40 sheep, and you can see the marshmallows. Great little innovation. 4 farms, 4 water sources, 15 frogs. And again, we're looking at the impact here of this particular microenvironment, about what the rules of adaptation are, how animals and ecosystems may survive and interact. And so we can see that the kids are learning a lot here. It's very kinesthetic, it's very tactile, and it's also a lot of fun. And it's really, really good early childhood tasks there for you to do and use in your classroom. So we can look at all of these different learning sequences. Let's look at your digital card, because let's face it, that's the challenge facing us now. I had some very, very good questions in the forum. What should Part A look like? How many words should it be? Now, it's a really, really good question. It's unspecified. But what I can tell you is the better you do Part A, the better you're going to do Part B. Because Part A should outline all of your thinking. Now, in my response to the forum, it is there. I did publish it. I've suggested between 1,500 and 2,000 words for Part A. Now, that may shock some people, but you think about it, you've got 2 learning sequences. You've got 2 different substrands of science, Earth and space, and then biological. You've got 2 different groups of learners, an early years or an early primary or a late primary, one combination of those. What you've got to do with this task then is to come up with a pedagogy embedded in each of those settings. And using that pedagogy, illustrate how that's going to work through your digital card to bring about effective learning for individual or small groups of students. So it's going to take you, and in my response to that question, I do outline a structure, and I do suggest it is going to take you, and it was also in last week's Zoom session, it's going to take you, 1,500 to 2,000 words to set this task up and to describe what you've done, why you've done it, more importantly, include some literature and bring some, attribute some academic sources to your thinking. It was badly lacking in assessment task number 1. Not enough people actually went to the literature to support what they produced. In this one, you're going to have to go to literature and support yourself and support your argument, because it says that use professional literature to write a brief comparison of 2 alternate pedagogies for science teaching. Now, you may think 1,500, 2,000 word is not brief. Well, compare it to a book. Compare it to a PhD. Compare it to an encyclopedia. Compare it to something of that scale, because really, you could write that much on this topic. But you've got to strip it down, make it simple, and have a look. I did make suggestions on how to do it. That's just a suggestion. My real suggestion is make sure you do it. Pay attention to setting up this task well, because if you set it up well, then the digital cards, really will do, will be a fait accompli. We'll be able to see what you're setting up, why you're setting it up, what pedagogy you've chosen to highlight, how it connects to other pedagogies, and how it links to your learning sequence. And the digital cards will speak for themselves. So we know it must be in digital format. I had some really good questions too about that. What does that mean? And it has to be printable. Yes, it does. It has to be printable. Okay, and I'll give you an example in a minute about what that might look like, so just to alleviate some of your stress there. But again, it's got some conditions around it. You've got to do 2 of them, and they've got to be at 2 different ends of your curriculum. So if you're an early childhood teacher, one of them must be on either on Earth and Space or on biological sciences. Okay, and it must be early years or early primary. If you're a primary teacher, it must be biological or space and science, and it must also be on the early primary or the later primary years. Our aim,
Colin,
Yep.
sorry, I'm just confused. Sorry, it's Lisa. Can I do, because I'm kindergarten teacher, just under the ECT program. So I was going to do the 0 to 5 using the QKLG for one digital card. And then for the other digital card, I was going to do PrEP, which was the foundation year. Is that okay?
That's fine, yeah.
Yeah, okay.
Yep.
Sorry to interrupt.
No, you're not interrupting. And again, it's been another really good question I've had on the forum. Do I use the foundation? Foundation year is a stage-based curriculum document. It's probably a bit like year 6 and 7. But there's two, the 6 and 7 and also the foundations and 1 and 2, really stage-based learning. It's not age-based learning. So the early years curriculum is all about transition to schooling. So the aim is that you as a teacher will draw down from the foundation year because it's meant to be transferable, backwards into the early years as well as forward into years foundations 1, 2, or 3. So, by all means, the foundation is a good one to do. If you're in early childhood, pick a foundation unit in ACS, pick a learning sequence from that. Then for your early years, look at your learning outcomes, identify some relevant outcomes, and pull some of that curriculum back into the early years program, because that's what it's designed for. Okay. So moving on, using plant trails, you can make a digital card out of plant trails. Now, there's some really good online tools, and in the Moodle this week, I tried to go through and give you a whole string of things that you may want to use as simulations, as activities that you can include in your digital cards. And the whole aim there is to be able to build an investigative, observational, predictive, and inferential strategy around your digital cards, so that it's not just simply go here, do this, have a look at this. I mean, you've got to give them some reasons to have a look at things. It must be contextual. It must be constructivist. So there's no point just sending them to have a look at something. There has to be a purpose in it. And that purpose must ultimately link to the learning outcomes for what you're trying to do. So the essential nature for trail is it takes students for a structured observation experience. And the Gould League has a great one. It's really good to do. And it may be something like that may be part of where you begin your digital card. You can look at significant features of plants and you become more sensitive to different plants in different environments. The Botanic Gardens too, the Australian National Botanic Gardens website, is also brilliant, and it looks into Indigenous people's use of plants. So here, just between that and that, we have the potential for an exciting digital card where we could look at traditional Western plants and definitions, and then we could look at Indigenous applications and definitions of plants. And we could build up some cultural perspectives around that, and we can use our science to understand those cultural perspectives. A wonderful little digital card. Plant growth and the cycling of matter. There's many experiments you can do. Growing beans or lentils in soil, taking photographs, charting the way shoots and roots develop, using mobile phones, dare I say it. As my time in Queensland education was a brief one, only 2 or 3 years while I was setting up a baccalaureate in Cairns. But prior to that, mobile phones were always part of my classroom activities. They're just brilliant. There's free software on mobile phones where you can do little polling events where you can show the kids pictures and say, oh, well, here's a little short answer question. So A, B, C, or D, what do you think's the right answer? And that excellent diagnostic stuff. And yet many schools ban the use of mobile phones. And yet you can, in a science class, send kids out to different sites around the school, get them to take small videos, get them to take small photos, and then they can simply text that photo back to home base, where their team at home base can be piecing together a little project that they've got to present to the group in 15 minutes' time. All of these real-time learning events, and we can use traditional tasks, but we can bring to it technologies, and we can do some really interesting things. Differing amounts of water, soil, and cotton wool, growing plants in different contexts. All of this can be done. We can add a technology dimension to it. We can add some maths and data charting, data logging, and all of a sudden, we've got a great investigation. Summary. We can look around the school ground. School ground invertebrates provide great opportunities for learning sequences. They really do. And some of the scientific processes we can focus on there, animal structures, animal functions, adaptation, reproduction, animal life cycles, ecological concepts such as food webs, energy flow, energy conversion, all of this, all of these different things fit into that very, very simple task. Animal behaviour also introduces investigative principles, a powerful way to engage children in learning about science, processes and practice, because animals are observable and we have a range of media by which to observe them. We can even observe dangerous animals and we can do it in a safe way. And the biology of plants can be explored in the context of school ground plants, looking at plant function, plant structure, reproduction, and the cycling and recycling of matter. So there's so much we can do in this little task. So much that we can do and look at existing units of study and learning sequences. Some more things that I've written down here. We've got the Piaget site, Colorado Education. Wikispaces, there's a little games in ed. You've got a whole lot of science simulations there worth looking at. And the reason why I'm promoting these is so that you can start to curate your resources for your digital cards. That is, go to these different sites. For instance, Science Kids New Zealand hosts a whole range of games. PB Skids also holds a whole range of games. And these games can be useful little introductions or forays into a learning area, depending on where you intend to use them in your digital card. So what I've got here is an example, and this is Miss Triple X, and I, it's not what you think, as I said, shame. The reason why it's Miss Triple X is to actually hide her original identity. But this is a student who's completed this task. And here is her digital card on the right-hand side of the page. Now, the first thing I want you to look at and note is the grade age. And of course, this tends to explain a little bit about, the physical features of this card. A, its presentation. B, its formatting. Would anyone like to comment? Give me their first impressions of that as a digital card. Would you look at that? For instance, it can be printed. But what it does, it actually links here. For instance, this student has built a Weebly site, and it links just under here, Earth and Space Sciences, the solar system. And what happens is they get a printed copy of this, okay, and then they go home and with their parents, they simply enter the address of the Weebly site and this card appears live. All the cards are then hyperlinked. These are little embedded videos. As you can see, they've got little triangles in the middle. Okay, another little sing along with me. And these are all songs that they can learn at home and come to school and sing. So anyone like to comment on this as a format?
I think it's great, Colin. I love the little bubbles and the numbering. It's quite, it's sequenced well. And the colour is really good too, to prompt the children through the sequence of activities.
Yeah, it does. And they all look different too, don't they, Loretta? I mean, they don't look like they're repeating, they're just going to a hyperlink, do they? They can actually look at it and they can deduce something about where they're going. So it's a little bit engaging too, isn't it? It's like a wraparound strategy. You can feel it wrapping around the learner's inquiry process. And again, these are all just curated resources that this student has found online. She's built her little Weebly site and she's used the freeware of Weebly to actually construct, just a hyperlinked web page. Essentially, that's all it is, with 5 embedded resources and the word activities. So you come here to do stuff. That's what you come here for. It's explicit. A couple of the questions I had around it. Do the text and images complement one another? Yes, I think they do. I would worry, though, lexically, it's a little bit too dense for year 1. There's a lot of words on that page. So you're going to be relying a lot on the parent or guardian interaction, for students to use this card independently, because that's one of the criteria, remember? Card to learn independently. You're flipping your classroom here. And you may, for instance, get half of your class to work on this, while the other half, for instance, may be engaged in investigation with you, which may involve some tactile experiments, related to Earth or a whole range of different things you may want to do. And then the following lesson, the other class, half of the class, may pick up the digital card and you may work with the smaller group again. So, it's the affordance you get from the digital card here. And we can see, there's quite a bit of text in this card. And I would be asking myself, could the student have used video or audio? A little talking head of themselves to introduce what to do. and then to have some keywords. So there's a link between the instruction and you're building a literacy component in. Little things you could think about. Is it a cohesive learning sequence? And I think the thing that suggests cohesion is the numbering, as Loretta pointed out. 1, 2, then we go over here to 3, and down here to 4, or 5. Oops. Is there is there scope for some confusion there? Small point. It's a small point. But when a child gets home and they're independent, you want them to be confident. So design issues do come into play. Is there an identifiable pedagogy? And if you look closer, you can actually see, yes, there is. It's actually the 5 E's. And it's very hard to read from this particular task because it's so small. I mean, I'm putting this up as an illustration, that's all. But it's essentially, it's a digital card implementing the 5 E's, and each of these activities represents one of the stages of the E's. So is it skillfully applied? My judgment would be yes, it is. It's quite well applied. It's been thought about strategically. It's gone from its engaged stage. This does look like a wonderful little engaging activity on the solar system. And then a little song, okay, to explore the activity, explore connections, and it goes on. Okay, so it's quite a good example of a digital card. And again, it's done using Weebly. And what I'll do tomorrow is in our discussion forum, I'll put up some, if no one has ever heard of Weebly before, I'll put up some links, I'll put up some resources to help you set up a Weebly site. It's actually very easy. Once you do it, you'll fall in love with Weebly. But just a caution, Education Queensland schools, some of them block Weebly. Okay, so it's an important thing. But this is not all the students done. Now, this is the student interface, right? This is what the learners get. That's what they print out and get taken home. Okay, and you probably laminate them, have a class set, because you can keep these resources. Once you curate them, they're all in one place. Okay, and then you can send home the card for students. But what this student then went on to do, okay, in her assessment, she put together the teacher's elaborations. She sort of said, this is, she's already done part A, where she predicted she was going to do all of this. Then she produced the student card. And then she said, for the educator, here is a user instruction card for the educator. So it's the educator elaboration. And you can see it's year 1. The topic is the solar system. She links it to the elaborations. She identifies her pedagogy. And again, see part A. Okay, she's now linking back to her own resources. Platform Weebly, Miss Triple X. She's got her Weebly site, link to it. It'll take us to the Weebly, which is the interactive live card. External links, she's expressing here and acknowledging the resources she's used. 3 external links, as you can see, related to each activity. And the important thing, if you're using Weebly, sometimes it's password protected. So if you're using Weebly, make sure you either provide the password to your marker or you make it password non-specific so that it doesn't get the marker's able to mark it. Because part of marking your card is to go to your Weebly and make sure the activities work and they achieve the goal that you're setting for them. So it's quite an elaborate task, this, with digital card. Your marker will pick it up. They'll look at your pedagogy. They'll look at the student interface. They'll look at the teacher interface, your intention, and then they'll check and make sure all of your resources work and that they actually do achieve the purpose that you say they achieve. It's consistent with what you say in part number A. So there's a lot of marking in this. I know there's a lot of work in this too, but it's all about alignment. It's all about aligning things, putting the student card, giving the teacher instructions. You can see it builds upon the illustrations in part A. Really important thing to do. Because the first thing your marker will say is, well, is it consistent with what you said it was going to do in part A? Yeah, it is. The student has included both a student version and a teacher version so that we can clearly see their interpretation. Here's what the student sees. We can see it's good fun, it's sequenced, it's colourful, it's engaging. Okay, all of the positive reasons she put it together. And it has clear curriculum links. It's consistent with the pedagogy she describes. Okay? It's embedded in a stable learning repository, a Weebly. So it's not going to disappear overnight because essentially it's there. And it narrates a detailed learning sequence. Yes, there are some problems. Yes, it's text heavy. Yes, it doesn't follow 1, 2, 3, 4, 5. You have to hop around the page a bit. But, you know, they're pretty minor problems. If you give it some more thought, you could then think about audio, you could think about video, you could think about putting in, you know, oral instructions for younger learners rather than detailed text, you know, and again, a nice way of doing it. The student then repeated, Miss Triple X got her second online thing happening, and she did her kindergarten card. And as you can see again, there are 5 stages, and same criticism here. It does link once again to her Weebly card. Notice she's done a second substrand and looking at the life cycle of a plant within a particular unit, and she's put together her resources. There's a learning sequence there. We know it goes a little bit clockwise, and hopefully the kids will get that. Okay, maybe they will, maybe they won't. It could be considered a design flaw, but you can see once again a little bit very texty, lexically dense, but we can see that the activities have been well chosen. We can see the text and images actually complement each other. It is about biology and plants, and we look at that page and we can see lots of images about plants. We can see lots of activities around plants. You can just see the children dying to get going. Again, would audio and video add value to this? Is it a learning sequence? It looks, smells, and tastes like a learning sequence. Is there an identifiable pedagogy? Well, you can't actually see it because you need to read closely. But when you read closely, it's play-based. And that comes along very much at the early stage. Sing along with me. So she's using play-based learning is her pedagogy. The second one, let's play a game, and it's a simulation. Okay, pick and paint. We can see this, you know, read along with me. So we can see all of these really, really interesting play-based learning activities geared around the life cycle of a plant. So the pedagogy is not only clearly identified, but it's skillfully applied in this learning sequence as well. Once again, she went on to provide an educator elaboration. So here is the student version. Here's what the learner gets. Let's take another look at that. Quite a nice little learning resource, colourful, a little text heavy. Probably unnecessary for the learners here, progressing links towards the Australian curriculum, okay, and listing the, you know, that's good for the marker to know because it's in your face, you get reminded, but, you know, it's probably not something you'd put on your digital card. Instead, you would include it here in your teacher elaboration and sort of say, look at this, the links to the early years learning framework, outcome 4.2 and 4.3. We can see it progresses, it transitions to the Australian curriculum. Look at all of the knowledge the student is imparting here. You know, she's on show. And basically saying, you know, not bragging, simply saying, this is my approach to teaching this. These are the integrations I have made into the curriculum. These are the connections that I think are explicit and important. And you can see that she's gone on to look at play-based teaching and learning, a link to her Miss Triple X site, and she's got her external activities clearly listed for us and what those activities are. And once again, audio instructions are provided at each activity. Look at that. So she's actually looked at this and sort of said, well, wait a minute, I've put up the text, but they're kindergarten kids, so chances are they're not going to be able to read the text, so I'm putting up audio as well. You know, it's a pretty thorough analysis of the learner, the science, and the challenge. So, you know, we look at the digital card, there it is. And yet it represents a lot of thinking. That will all be detailed in part A. And in part B, it'll be presented for the student. And then for any other teacher who ever chose to pick it up and use it. So it becomes totally explicit. There is no confusion around this learning cycle and the pathway for these independent learners. So why it works. And I'm going to open the floor to you guys in a minute. This is just my thoughts. There are visible and transparent links between part A of the assignment, the rationale, and part B, the digital cards. They'll speak to each other. Everything she said she was going to do in card 1, she's done and explained why. Everything she said she's going to do in card 2, she's done and explained why. She clearly identifies her substrands. She locates relevant and applied pedagogies. Okay, really drawing them down from existing primary connections units. Each card is highly printable, can be laminated and become snot-proof, which is really valuable at this learning age. There's only one hyperlink from the card to the Weebly. Once you get there, everything is hot linked. Everything works from the repository. And that's really, really good for navigation because people aren't going to get lost. They'll go from the card to the Weebly and from the Weebly to each of the activities. And I think you would identify that most parent ICT skill sets would be able to follow that design. She's made a strategic effort to make the cards engaging. So there's lots of text, there's lots of image, and they both interact and support each other. They actually say, come get me. Come learner, get involved in this. The screen real estate on each card is just brilliant. Okay, she set out a sequence, and look, they're not all linear. Small criticism, but most kids can identify numbers, and if they can't, that's a great way for the adult, the more capable other, to jump in and say, well, where do we start? Oh, there's number 1. What comes after 1? 2. What comes after 2? 3. So you're starting then to get the whole notion of the learning sequence happening and a little bit of learner autonomy. Each digital card successfully flips the classroom. Now you can see that by using these cards, she's actually gaining credit in her face-to-face interactions. The kids will come into the classroom, they will have worked through certain tasks, they'll have a base level entry point, Bloom's taxonomy. Okay, we can look at, level 1 of the questioning hierarchy, if you like. They've come in at that observational level. The teacher can follow this up with one-on-one teaching and link to the second task or third task. Follow this up with some formative assessment while continue to engage parents, guardians and learners, extended learners, extending the classroom, extending the time of the classroom and its importance beyond 4 walls into families and homes and lounge rooms. So what we're seeing here is incredible affordances coming from this particular activity. Now, I think that's it. That is my last slide. So I'm just going to ask at this stage for your comments, your feedbacks, any questions you may have about your thinking around this particular assessment task.
Thank you for putting, it's Maxine, I actually don't have a question. I just want to say thank you for putting on the example. It really helps me have a more of an idea and a clear way of where to go.
Thanks, Maxine. I thought at this stage you're ready for it. A week or two ago, people may not have been quite as ready for it, but I'm thinking at this stage there's a lot of questions, a lot of really good questions, and some people really working, hungrily thinking, how do I do this task? I'm reasonably comfortable with science now. I'm comfortable with the notion of pedagogy. I think I understand the task, but what will it look like? So it's one of the reasons why I brought this up. This is one way it could look, and I think looking at it, you can see how it works. Most importantly. Any other questions or comments?
One comment. Sorry, Colin.
Fire away, yes.
With the example of the early childhood, I know you did say that it was quite wordy, but I think those would have been the instructions for the parent and the teacher to work with the card. Potentially, and she also had the backup, Loretta, of putting audio on, so so it could be played for the learner. Yeah, which I think was great. Yeah, it's a good adaptation, isn't it? And a simple solution. Yeah, and on the front page of our subject website, you'll see Voki is there. If you haven't used Voki before, it'll take you about 2 or 3 minutes to learn how to use it. And down here in the ICT section, IC tools and websites, Voki, really simple, does simple records you can just plug and drop into your presentations. Okay, so that's another way to do it. Anyone who's got OneNote on their computer and you've got a digital camera, it too will just shoot a little headshot video of you, and you can just drop it into your digital card, into your Weebly or your website, whatever it is you're intending to do. Does that make it more visible? What's required here?
Colin, it's Maxine. I just have a question. So the example that you show, could you not exactly copy it, but kind of a little bit follow the design point of it, or are you not allowed to do that? You are certainly allowed to do that. The student actually got the principal idea from another learning unit that she'd used and done. So, this is a good currency about good ideas. They travel and they hold their value. So if you're seeing a pedagogy that works, and essentially the card is a pedagogy, and it's done in play-based format, or the previous one was done in the 5Es format. But either way, it transfers beautifully.
and it's a format, it's a strategy, so feel free to use it. And it's like saying predominantly most people will submit a Word document, and they're not going to be criticised for submitting a Word document, okay, because it's no different really to a web page. It's just a different genre. Yeah.
Thank you, Colin.
Any other questions or comments? Are people surprised by this student's response? Had anyone else thought to put in a learner card and then teacher elaboration?
Yeah, I hadn't thought to do the teacher elaborations, but I wanted to thank you for answering the question about drawing down from the unit, from the foundations unit, and with using the Queensland Kindy guidelines, would we be able to, or do you want us to link to EYLF?
No, you're free to determine which one, Nicole, you're going to use there.
Cool.
So the only reason I used the EYLF in last week's short video and lecture was because it's nationally accredited and we have students in different states.
Yep.
So, yeah, and they may not have access to it. So just pointing where it was and what it was. So by all means, use the Queensland one if that's the one you're more comfortable working with.
Yep. And in relation to the example you showed, yeah, I think it presented really, really well. So I hadn't got that far yet, and I've only just started playing on Weebly in preparation for this assessment, and another one that I have that's multimodal as well. And I think, yeah, they've done a great job of making it look pretty. They
certainly have, yeah, and it's why it's worth showing, just to say, look, this is one person's interpretation. And it combines a very, very simple Word document for the teacher with hyperlinks and explanations and pointing to the model. And a teacher looks at that and gets it and says, I know exactly what you've done here. And when the learner looks at it, they can't see any of that. What they see is a journey. And I think it's really exciting for learners. So it works on both levels. Yeah. So, yeah, any other questions or comments or observations? It's just one way to do it. It's not the way to do it, but you can see just how explicit it is. And then when a marker looks at this, everything is so obvious to them that, you know, they're not guessing about what the students thought. They're not guessing about what the interpretation is. The pedagogies are explicit. The strategies, the learning strategies are explicit. The learning resources and the assets that they've curated are all explicit. And we can see everything's out in the open. You know, this is a really very transparent learning experience and can be used for that reason, therefore, and will add value both to the independent learner and to the class and the learning sequence when the teacher brings them back together. That's the one thing complaint we often have with ICTs. It gets detextualized from the classroom, which can be, kids can go down the ICT tunnel, the rabbit burrow and disappear. So the real skill in using digital learning and digital pedagogies is to bring them back together, to make it communicable and to make it community oriented. And that's one of the things I think this card does very, very well. And the little example. Any other questions or comments? If not, what I'll do is hit the cease recording and get this burnt.
One more, Colin.
Fire away, yes.
I have an existing Weebly, which is my portfolio. So I'd create a page in that. Is that acceptable? I don't want to go
Absolutely.
and create a new Weebly. I'd rather just create a new page within my own.
Lovely, Loretta. That would be perfect.
And then the digital task cards, can I embed that into my Weebly? Or do you want that submitted on the Moodle?
Look, I think be as explicit as you can. I mean, I will mark your work clearly, being the distance lecturer and marker. So what I'd love to see is Part A presented in essay discussion format. And then I'd love to see Part B presented with digital card number 1, the student version, digital card 2, teacher elaboration, digital card 1, teacher elaboration, then digital card 2, student version, digital card 2, teacher elaboration. And that would be all you'd need to submit. And then just along with your references. Yeah, because really all your thinking should be explicit in Part A. And when you get to Part B, the marker should just be sitting there basically enjoying a post-coital cigarette saying, oh, this is fabulous. Everything that they said is going to happen is happening. And look at this, great resource, and it works, you know. And so the marker's just sort of sitting there just applauding, you know. It may be one hand clapping, but they're just applauding saying, look, I can see the teacher at work here. And that's what the task is. Yeah.
Thank you.
Thank you. You're welcome.
Colin, I just have a quick question. I'm just following after Loretta's question. So I also have a Weebly that I've done. So even if it's like a whole unit on my digital design, I can just go and put a page in there and do science and put my 2 digital cards. It's not, I can do that. It's like not bad if I do that.
Maxine, that would be fine. And look, you'll do this as a teacher too. You'll just have the one Weebly site, and you'll just create different pages for it for different classes and different purposes. And it'll travel with you everywhere you go.
Thank you.
Yeah. And one thing I will suggest towards the end of the course is, if you're willing and you're in a group of students you're working with and know, swap. If you've built a Weebly, swap resources so that you're going away from this course, not with 1 or 2 units of science up your sleeve, but with 5, 6 or 7 done by students who are thinking like you, who are in that groove and who are trying to achieve the same sorts of aims that you're trying to achieve. So you can leave with, considerable resources up your sleeve. Yeah. So on that note, I'll just remind you, this is not a competition. We're all here collaborating. And this is one of the reasons why I'm really delighted to show you successful work from the past. It's a very successful interpretation. Not perfect, but it's a refreshing interpretation of how this task can be stripped down and simplified and presented. On that note, I'll say goodnight and thank you again for your attendance and commit this to record and posting. So thank you. Good night.
Thank you, Colin. Bye.